In trig, two particular types of right triangles show up lots and lots and lots. There are angle measures that tend to show up over and over and over again. So we need to be familiar with these two triangles. We need to be familiar with properties of these particular angle measures. The first one is a 45-45 right triangle. You might see it called a 45-45-90. I usually say a 45-45 right triangle. And the deal with a 45-45 triangle, these two angles are equal, right? They're both 45 degrees. And if they're equal, that means that the sides across from them are equal. So this is an isosceles right triangle. So instead of saying A and B for the legs, we'll say A and A. They're the same, right? So this is the hypotenuse. Remember, the hypotenuse is across from the right angle. We can figure out what that hypotenuse equals in terms of or using A. So we're going to use the Pythagorean Theorem, and we're going to say A squared plus A squared equals C squared. So we're going to solve this for C. A squared plus A squared is 2A squared. And in order to find C, I have to take the square root of both sides. Okay? So the square root of C squared, if I take the square root of a perfect square, I get what's inside, C. And over here, the square root of A squared is A. So that can come out here. But the square root of 2 can't simplify. So we just write it as A root 2. So what happens here is if we know that we have a 45-45 right triangle, we know that both the legs are equal. They're both A. They're congruent. And the hypotenuse is whatever A is times the square root of 2. And we're going to use this in order to find sides of 45-45 triangles without using the Pythagorean theorem. So here's how we do it. They give us a right triangle here. They tell us that one angle is 45. Well, if this is a right triangle and this is 90, remember the three angles have to add up to 180. So this other angle also has to be 45. So this is an isosceles right triangle. If it's isosceles, that means the legs have to be equal. If those two angles are 45 degrees, the two sides have to be equal. So x here, the value of x is simple. If this side is 10, this side is also 10, right? And then the hypotenuse, which is y, here's the right angle, here's the hypotenuse. The hypotenuse is whatever the leg is, 10 times the square root of 2. We could use the Pythagorean theorem here, but if we know that in a 45-45 right triangle, the hypotenuse is always the leg times the square root of 2, we save ourselves a little bit of time, okay? Now, number 2, look what they've got here. Here, they give us the right triangle. They tell us this angle's 45, which means that one's got to be 45. That also means that these two sides are equal, okay? Now, did they give us the leg or the hypotenuse? They gave us the hypotenuse. If they give us the hypotenuse, if we're going from leg to hypotenuse, we multiply times root 2. So what do you think we're going to do if we go from hypotenuse to leg? We're going to say 14 root 2, and we're going to divide by root 2. Well, those cancel, and that means that those congruent legs are both going to have measure of 14, okay? So if we go from leg to hypotenuse, we multiply by root 2, and if we go from hypotenuse to leg, we divide by root 2. That's how a 45-45 works. All good until we get something that looks a little weird, like right here. Notice they gave me the hypotenuse. They gave me that it was 16. How do I go from hypotenuse to leg in a 45-45 triangle? I divide by the square root of 2. So I have to take this 16 and I have to divide by the square root of 2. Well, we have to rationalize this, right? We've got a square root in the denominator, so we have to multiply by root 2 over root 2. So we get 16 root 2. The square root of 2 times the square root of 2 is 2. And then we can simplify this and we get 8 root 2. So this is 8 root 2. And since it's an isosceles right triangle, they're both 8 root 2. Okay? And you could check this. If you take 8 root 2 and you multiply by root 2, you're going to get 16. The next special type of right triangle is a 30, 60, 90. Okay? This is a right triangle where the smallest angle is 30 degrees and the middle angle is 60 degrees. And in a 30, 60, 90, the side across from the 30 gets the A. Okay? So the shorter leg is always A. Now, here's how we figure out a 30, 60, 90. If I were to double this here on the other side, this would be 60, this would be 30. I get right here, I would get an equilateral triangle. All three of these sides are equal, okay? So if this is A, this right here would be A, and what would be all the way across? A and A, this gives me 2A, okay? And if it's an equilateral triangle, that means this is 2A and this is 2A. Well, guess what? That's my hypotenuse, right? So whatever the shorter leg is, A, the longer leg is 2A. Not longer leg, the hypotenuse. I'm sorry, the hypotenuse is 2A. Now, we still need this part right here. So here's what we're going to do. We're going to come over, we're going to do a little bit of Pythagorean Theorem. We're going to draw that triangle. We know that this is A, this is 2A, and let's say that longer leg is B. We're going to solve for B. A squared plus B squared equals, and the hypotenuse is 2A squared. All right, so A squared plus B squared, 2A times 2A is 4A squared. I'm going to subtract A squared from both sides, and I get B squared equals 3A squared. Now I'm going to take the square root of both sides. The square root of B squared is B. Remember, I can take the square root of A squared, and I can take that A to the outside, and then the square root of 3 is stuck. So the longer leg is A times the square root of 3. Okay, so that's the relationship. Here's the deal. All of these have an A in it. That's what we want. So if we know one of them, we can find them all. So the shorter leg, the leg across from the 30 is A. The longer leg, that's across from the 60, is going to be the shorter leg times root 3. And the hypotenuse is going to be twice A, or double A, because of this equilateral triangle deal we get. So let's see how this looks when we try to solve some problems. Okay, very important to look at a diagram and figure out what you're looking at. I see a right triangle. They give me this angle is 30. Well, if this is 90 and this is 30, since the three angles add up to 180, that means this other angle has got to be 60. Okay? They give me one measure, and you've got to decide, is it the shorter leg, the longer leg, or the hypotenuse? Well, this 8 is across from the right angle, so this is the hypotenuse. Okay, so the hypotenuse is 8. Well, usually the easiest thing to find is going to be the shorter leg, because what's the relationship between the hypotenuse and the shorter leg? The hypotenuse is twice the shorter leg, right? So x is going to be half of 8, so x is going to be 4. And I would write that in so that you could see it. That shorter leg across from the 30-degree angle is always going to be half the hypotenuse. Now, the longer leg is the shorter leg times root 3. So y is going to be 4 root 3. You could do Pythagorean theorem there if you wanted. It just is a little quicker if you remember that the longer leg is the shorter leg times root 3. So longer leg equals the shorter leg times root 3. Okay? All right, now let's look at the next one. Always look and see what you've been given. Right triangle, this is 60, which means this angle up here is 30. So which side did they give me? They gave me the side across from the 60. That's the longer leg. So they gave me the longer leg. Again, go to shorter leg first. Well, if the longer leg is the shorter leg times root 3, what am I going to do if I know the longer leg? I'm going to divide by root 3, right? I'm going to reverse that. So the shorter leg equals the longer leg divided by root 3. So I'm going to take that 27 and I'm going to divide by root 3. I have to rationalize, and I get 27 root 3 over 3. So that is what? That's y here. Be careful, pay attention to that. 9 root 3. Okay, so this is 9 root 3 when I divided by root 3. Now, if I know the shorter leg, if I know the side across from 30, that's the shorter leg, how do I get the hypotenuse? You double it. What is 9 root 3 times 2? Well, that's going to be 18 root 3. So once you know the shorter leg, the hypotenuse is easy. Just double it. The hard part is going to be going from the longer leg, which is across from the 60. All right, let's look at one more. So they give me a right triangle. Here's my 60, which means this angle is 30. So which side did they give me? They gave me across from the 30, which is the short leg. Now, if I know the short leg, the hypotenuse is easy, right? What do? I double it. So 5 root 6 times 2, I get 10 root 6. Is that right? Okay. Now, if I know the short leg, how do I get the long leg? I multiply by root 3. So I'm going to take the 5 root 6, and I'm going to multiply by root 3. So this gives me 5 root 18. Now I need to see if that will simplify. What perfect square divides 18? 9 does, right? So 5 times 3, the square root of 2 is stuck, and I get 15 root 2. So all of those answers look really weird and really ugly, but that's okay. We did the same process every time. Okay, the last thing we need to do with these special right triangles is know their trig ratios. The trig ratios for 45 degrees, 30 degrees, and 60 degrees show up all throughout trig. You will need to memorize them eventually. The more we use them, the more you'll know them. You can always go to a triangle and figure them out, but if you have them memorized, that makes it a little easier, okay? So here's what you do. We know that in a 45-45, the legs are both A, right? It's isosceles, and the hypotenuse is whatever the leg is times root 2, okay? So if I wanted the sine of 45 degrees, well, sine is opposite over hypotenuse, right? So from 45 degrees, what's the opposite side? A over, what's the hypotenuse? A root 2. Okay, so let's come down here and let's simplify that. These cancel and I get 1 over root 2. I have to rationalize and I get the square root of 2 over 2. So the sine of 45 degrees is root 2 over 2. You can figure that out, but if you memorize it, it'll make life a little easier as we go along. Now, look at the cosine of 45 degrees. Here's 45 degrees. Here's my adjacent. That's A over my hypotenuse is A root 2. Guess what? It's exactly what sine is. So the square root of 2 over 2. The sine of 45 degrees and the cosine of 45 degrees are the same because those two sides are congruent, right? Now, the tangent of 45 degrees. Tangent is opposite. That's A over adjacent. That's also A. And what's anything over itself? 1. Okay, so there's the sine, the cosine, and the tangent of 45 degrees. We could also find the reciprocal functions. We would just have to flip those and simplify if we needed to. Okay? Now, in a 30-60 right triangle, remember the side across from the 30 is A, the hypotenuse is 2 times A, and the side across from the 60-degree angle, the longer leg, is going to be A root 3. Okay, so let's look at 30. We need opposite over hypotenuse, opposite over hypotenuse. So we're going to say A over 2A. Well, this simplifies pretty easy. Those cancel and we get 1/2. So the sine of 30 degrees is 1/2. The cosine of 30 degrees is going to be the adjacent, which is A root 3, over the hypotenuse, which is 2A. My A's cancel, and I end up with root 3 over 2. So the cosine of 30 degrees is root 3 over 2. The tangent of 30 degrees, we look at opposite, that's A, over adjacent, A root 3. This one's going to need some simplifying, so let's look. A over A root 3, those cancel, and I get 1 over root 3, right? I have to rationalize, times root 3 over root 3, and I get the square root of 3 over 3. So the tangent of 30 degrees is root 3 over 3. Okay? Now we're going to do the same thing with 60. Opposite, whoops, I didn't mean to do that. Opposite 60 degrees is A root 3 over hypotenuse, that's 2A. Those A's cancel, and we get root 3 over 2. The cosine of 60 degrees is the adjacent, the leg that touches the 60 degrees. That's A over the hypotenuse is 2A. Those cancel. I get 1/2. Notice the relationship here. That's important. The sine of 30 and the cosine of 60 are the same thing. The cosine of 30, the sine of 60 are the same thing. And then the tangent of 60 degrees is the opposite. That's A root 3 over the adjacent is A. Those cancel, and I get the square root of 3. Okay? So these are values you need to become familiar with. We'll work a lot with them so that you see them and become familiar with them. If you can memorize them, that's good. If you have to think through them, that's okay too.